So I'm very, very happy to have here Ricardo Sisnett as our next speaker. Ricardo works within a company I haven't seen before. It's called modl.ai. As a lead engineer, we're extremely happy to have Ricardo as our lead engineer because he's this person that actually appreciates both engineering and research and product development. So he really sits at this tripod, helping everyone communicate very well in the company and sort of delivering very well. Ricardo has been here, Ricardo Sisnett has been here in the first summer school, 2018. This is where we met. Maybe we met a bit before, right?
Or, we met at Gecko, 2017.
Yeah, exactly. So genuinely he has an interest in AI and games research and development and engineering. And today, he's coming back as a speaker, 4 years after, talking about architecting games with AI in mind. Sisnett, the stage is yours. Welcome.
Thank you so much for... Thank you so much, Georgios, for the introduction. I'm Ricardo Sisnett. I usually go by Sisnett because there's a lot of Ricardos where I come from, so it was a little bit easier. Thank you for having me. It's super exciting to be as a speaker here, and I appreciate your time as we go through these slides. First of all, what is this talk even? Or a few disclaimers, so you know what's going to happen. This talk is completely empirical. This is based, obviously, on my experience and a little bit of what I've been doing at Model. In the words of Julian, is like my opinion, man. It's going to get a little bit spicy, definitely not as spicy as Matt's featuring Julian presentation from yesterday, but we'll do a couple of controversial or very opinionated. We'll send some opinions out there, and I feel this presentation is either going to make you go like, well, duh, or, I never thought of it that way. I don't think there's going to be an in-between. I feel if you've done some of this work, it's going to be like, yeah, this is obvious or should be obvious, or ideally it would like inspire you to look at it in a slightly different way. What this talk is not an end-all be-all kind of proclamation. This is not like the solution for everything. As I said, it's highly empirical. It is not a silver bullet forge. I will not give you like 3 things that you can do to solve all of the problems. I think we still have a lot of work to do here. And it is not a company pitch, but I will talk a lot about Model because it's what we do these days, and it is very topical. Lastly, an apology to Sam Earl. I will not be wrapping this one. And since we have been seeing this everywhere, I figured I would put it. By continuing this presentation, you're accepting cookies. So a little bit about me. I know Georgios did a little bit of a great job introducing me, but this is me. I sometimes do weird stuff with my hair. That is normal. I am originally from the town of Guadalajara, Mexico, sometimes dubbed the Mexican Silicon Valley. And I fell in love with games when they used to look like that. Basically, when I was 5 years old, I saw this and loving fuchsia since then. Games have been my life, or my main focus of my work, my entertainment, and a little bit of research as well. These days, I work as the lead engineer at Model. Just a quick explanation of what we do over there. What we're trying to do is basically all of the stuff you hear here, or the cool techniques that different companies are doing on their research labs. We're trying to productize that and bring it to all and smaller game companies. So we're trying to find ways of doing, DRL and PCG and imitation learning in such a way that we can just give it to new creators and they can just, go crazy on it. Before that, as I said, I grew up in the Mexican Silicon Valley, so I was actually forged in the fires of enterprise software, so I worked in databases and server code for a while. Not as fun as working in games, but definitely very formative in the architecture and long-term software maintenance things, which the games industry is not great at. And I think my claim to fame and why Georgios and Julian even talked to me is because I worked at Riot for 6 years. I had a chance to work both at Legends of Runeterra and League of Legends. And over there, we did both the MCTS adversarial AI, where you can play the game against, and then a DRL agent for game balancing, which recently was published as a talk, so I can now talk openly about it, which is awesome. Okay, so let's start from the beginning, right? Have you ever been in this situation? You're maybe a PhD student, maybe you're a new indie studio, and you're like, hey, I've heard about this very cool technique that we could apply to our game. Maybe it's PCG, maybe some DRL for testing. And then the bean here goes and pitch to the engineering team, and then this is what they start hearing is like, well, you cannot actually do that because data doesn't work that way, or we cannot do it without a big refactor, or oof, it's legacy code, so we cannot touch it anymore because Jim left the company, or oof, we don't have the time or the scope for this, and then we end up with a very sad bean, right? And this is basically what we have to deal a lot with modl, because companies come to us with their games and they go like, yeah, we want your cool AI stuff, and then we have to do a lot of work to help them integrate because usually games are not ready for this. So I'll take a quick sidestep and talk about kind of like why I feel this is very pivotal and why I pitched this presentation. Is I feel we're like close to a paradigm shift, right? If you see some of the companies that are here today talking about AI, it's the big games, the big names in games, right? We have Ubisoft, we have EA, we have Sony. The big companies are paying attention to this stuff. So I feel now it's becoming mainstream. It's coming out of the labs and coming into the spotlight. So that will require a paradigm shift. Again, my perspective. And what do I mean by that? When at the beginning we were like, let there be games, there was no separation of concerns, right? We would use the sprite size to check for collisions, and we were like poking the processor with a stick. Everything was like a big mess between the rendering and the game logic and the game engine. There was no separation, right? Eventually, we figured out that the render loop was a good idea, and then engines started going that way. We were like, yeah, let's have a render loop. Let's batch our stuff. Let's batch our draw calls into the GPU, and of course, discrete GPUs help a lot to do this. And we separated the rendering from the engine. And then we figured out that there was this stuff that we were doing over and over and over again, and game engines came to life. And we abstracted physics, and we abstracted networking, and we abstracted controllers. And now the game logic, the engine, and the rendering are kind of separated. And if you look at modern game architecture, they basically look something like that. Obviously, it's very abstracted. But you have your game logic separated from your engine code, separated from like your rendering kind of like loop. And then we also have the whole networking loop that does prediction and lag correction and all that stuff. So basically, every time we've had cool technology for games, we have shifted our architecture to accommodate it better, right? So coming back to this, what is the paradigm shift for accommodating new AI in game engines? All right, so I brought my gal here, Christina Aguilera, and to talk about what a bot wants and what a bot needs. This is a list that I kind of try to steal a little bit from the talks to give them some names. But what we need is, we need your game to be knowable for the AI. That means we need to know what our interfaces are for getting observations, what are interfaces for acting on your game, what are interfaces for collecting data. Forward modelable for a bunch of techniques, right? Like Julian, I think, did a very good job kind of like classifying which techniques would need this. We need it to be reasonably fast. So that means that if your game has a lot of animation and game logic kind of like interconnected, we can only accelerate it so much. It needs to be deterministic and seedable. And I will really emphasize seedable, because people will tell you their game is deterministic. Once you start it will do the same thing. But they will never, the mechanisms for seeding will be sometimes very hard to kind of like interact with. And clonable, I think this is something that we didn't discuss a lot when Julian was talking about forward models, but we need to be able to copy your game state. So for the love of God, separate your game state for the engine state. Otherwise, we cannot clone the entirety of Unity. Stable, we needed to respect the Markov property to a very good degree. I mean, there can be a little bit of hidden state, but just a little bit. And standalone, what I mean by this, your game should be able to run without having to connect to 7 servers and authenticate and, right? Make your game run as your game, standalone, and then add the rest of the services around it. And data able, make your data versioned and make your data clean. And I'm gonna get into all of this in a quick second. But basically, if you can subscribe to these things, we can then do AI, I think. Or at least that's been the kind of stuff that we have been working with the companies we interact with. This is the kind of stuff we're always solving or helping them solve. So I'm going to use this thing as a way of driving what I mean by all these things. Candy Match 3 Kit is an asset in the Unity asset store. It costs around $150. It is a very well-made asset. It is so well-made that companies will lift it and reskin it and basically build businesses on top of it. It has amazing reviews. It's been in the Unity asset store for like 5 years. And I'm pretty sure this dictates a lot of how modern puzzle tree games are built in Unity, just because of popularity. So at one point earlier this year, we had an intern with us for 3 months. And match trees is something we do at Model, right? Like we have a system that generates levels for match trees, and we have a series of agents that can play match tree games with different proficiencies. So we figured that having our own little kind of like test bed would be great. Pay $150 for Candy Match 3 Kit, plug it to our stuff, and then we can do a bunch of experiments, right? Well, I mean, we had the intern for 3 months. He got some support from the core team, but we found a lot of very gnarly issues with this thing. And I think what we had to do with this game is basically what everyone would need, almost anyone would have to do with any game, because it illustrates very well the kind of problems that I'm kind of like pointing at in the previous slide. So starting from the end, the good news is that we got it. Here we see the game is running pretty accelerated, and then a bot loads a level and starts playing it. This is a random bot, if I recall correctly, so it's just going to like go at it for a while. And basically, the basic thing we needed was, the orange thing is our puzzle dev kit, and we just need like a communication API so that we can, push stuff into the game and read stuff out of the game. The dev kit is written mostly in Python, so we need Unity to kind of provide some sort of like, API socket, something like that we can hit. But that is basically all the setup that we need is just a little bit of that communication API, and that should be it. The problems is then we started to try it out, right? And then when we tried to forward model, we start finding a bunch of woes. So how many people here are familiar with Unity? OK. So if you ever needed to do anything random or generate a random number in Unity, and you look up the documentation, this is what comes up, right? Unity.random, whatever you need. Can anyone see like already a kind of a problem here? This is a global state. There is only one Unity.random. This is a static class, right? That means anything that happens in your game will touch that state. So a very funny thing is we were starting to test out our forward simulation. Seems like everything is going well, but every now and then it just diverges. Like run it once, run it twice, perfect. Run it again, perfect. Run it again, slight divergence at some point. And it was one of those things where like, what is happening? No obvious answer at the beginning. And turns out that if you have played a match 3 game, you know of this feature that will suggest you a match, right? So if you're playing the game and you don't press on anything for like a few seconds, then it'll be like, oh, this match. So the game has all of the matches in memory, and to suggest a match, it will pick one randomly. So if our bot was playing the game, and for whatever reason there was a stop of 3 seconds, then this thing would kick in, our bot would completely ignore that suggestion, but then the random state had been already like changed, so we would see divergence. Another very fun one is dictionary in C#. Did you know that dictionary iteration is not order guaranteed? So if you insert A, B, and C, and then you say, give me what I just inserted, you could get CAB, CPA, a combination of the previous ones. This game stored its events after like some tiles would match, and then explode this thing, do this other thing in a dictionary. So then when it would go through it, you could get slight divergence because sometimes one thing would hit the random state at one time, and then, or there was no ordering, right? So you could hit the random state first, get a result, or some other combination of that. And the dictionary, you cannot see it from outside. It's internal state from C#, so you cannot do any of it. And lastly, the state copy was very, very annoying because there was a lot of basically big game objects doing a lot of stuff. So we needed to clone all of that thing, and that was no bueno because Unity object lifecycle is kind of like its own thing. So we had to do quite a bit of work on some of these. We created something that is called scope random. So basically, you just have a dictionary of scopes and seeds, and then Unity lets you reseed anytime, so you can keep some sort of tracking for that. Please, for the love of God, use ordered dictionary or sorted dictionary. Dictionaries and Unity already are not friends, so just use ordered dictionary and save yourself a lot of trouble. And lastly, please separate your data bags from game objects. You can have just pure C# structs as data. That's great. So I mentioned this in the Discord the other day when someone was asking about some of these like interacting with engines and engines being a little bit hostile to AI. How many people here have heard of MVC? It's a very web-based kind of like approach. But for some reason, we don't do it anywhere else, and it is actually a very useful approach. It just tells you, your data, the model, is independent and it has no functionality. You have a view that can show whatever data is in the model, and you have a controller that can change the data. This actually is kind of like what ECS is to a degree, because you have very separated concerns of who can change the data and who can be the data kind of thing. And then this makes it so easy to serialize or copy any of this stuff because you only need to interact with the model. I will not get like super deep into it right now. We can talk about it later. But it is not a silver bullet, but I think right now it's probably is the closest we have with like at least a little bit of plating on it, because it does solve a lot of these problems. Like these days, that's mostly how I just go at it. Is like how do we MVC this thing to start solving some of like these fun stuffs. And this is a little bit of the serialization issue. If you look at Unity serialization, it looks like that. That is definitely not AI friendly at all. And what we wanted was something like this. Okay. So this is where we just basically created data bags that would represent what each tile had, and then the format is not super important. But instead of having all of that stuff, this is now what the internal state looks like. And then this is much friendly for AI. And as you can see, we're using already like kind of like one hot encoded vector. So we think this could also fit pretty well into like DRL or some other things we have in our future roadmap. So another very fun one. Your game needs to be knowable. What I mean by that is we need to understand if we do something and we get a result, is it like done? What is the intermediate state? What is happening? So once we figure out serialization of state, we're trying to manipulate the state, right? And our bot will send moves to the game. The move would execute, and you could see it execute, but then the bot would get an error because it was the same state. Like you would see the same state twice. And what was happening is the applied gravity method, which is the one that would start pulling things down when you have a match, was an asynchronous method that could have a random amount of delay. Like you could add a delay to it. And they were adding delays in a bunch of places. And basically, you could tell the game, hey, make this move. And it will be like, yeah, gotcha. And it would finish that move like 0.75 seconds later. Why? This is the stuff of nightmares for AI. This is like the bot is sending an action, is getting a result. It was getting like it went, but it was not freaking happening until a second later, which is a lifetime for the bot. So, So what we need to do, oops, my title kind of died there, was wait for it. So we had to implement like a wait system for verifying that the move had finished. And why they could get away with this, with like when people were playing, is because they basically locked the input as they were doing the movements. So there was just one flag that was like, you don't get any input, but the game was not. The game was just going, in its waits and yielding, and then using animation to kind of like time stuff, and then it would return there. Like it would finish kind of like the board settling. But from the AI perspective, we're not using the input, right? Like we're not touching the screen. We were trying to interact directly with the state, And then we got these influx states several times. You could actually get some very funny ones where it was in the middle of some resolution, so you get like very funky states. So as I was saying earlier, what I mean by knowable is we need to know when we can act on your game and when we can read state, and you need to help us with that. Otherwise, we will get into these situations of the bot being very confused when you tell it, yeah, your move went through, and then he's like, but why is the board the same? This one is very important for me, standalone and stable. So I was talking about standalone a second ago, which is your game shouldn't require 17 servers to be up, right? We see these very often. We're working with a small studio. They have their prototype. We can run our bot on it. We get good results. Later on, we try to do the exact same thing with a new build, and then we start getting like all sorts of weird errors. And it's like, oh yeah, we just added the account system, and now your bot needs to have an account. And then we want to run 20 of these in parallel. Great, now you need 20 accounts, and each one has to have a different email. So we have had to literally have someone create 20 different email accounts, subscribe 20 different accounts into the game, and then give that account to each one of our bots. Again, why? You're making your life so hard and my life so hard. And then, oh yeah, dismissible takeovers. Match-3 games, as mobile games, they have a lot of sometimes advertisements or promos or hey, the store has this thing, and then it just overtakes. And then the bot is like, I want to play the game, and then the overtake is there. And we have to, there's always workarounds to force a click or pretend that we go to the store and back, etc. Please make all of that separate from your core game. And the second one is subordinate your animation to your logic, not the other way around. Do not time things as when animation done, then this happens. Because again, that's the stuff of nightmare for AI. It makes it very hard to accelerate your game. So if you need a forward model that is reasonably fast, then you're shooting yourself in the foot. Animation, since it's a little bit more tricky, can sometimes have a little more floating point error. So again, shooting yourself in the foot if you are trying to time your logic of the game with your animation. And a bunch of other things. You have a little bit of frame drop, your animation doesn't finish correctly. I think MVC can help a lot here because animation pertains to view and logic pertains to controlling. And make your presentation layer, meaning everything that ends up in the screen for the player to touch or interact with, make it very dumb. Your buttons should only show stuff and receive clicks, nothing else. And this is more code from that game. This is what I mean. After you click on two tiles, this thing will start a tween so that the tiles will move into one another. It's beautiful. It takes 2.25 seconds. And then when it completes, it actually does the matching right here. Again, why? You could do the match and then do the animation to present the new state, and that would work perfectly. And again, this is something that is used quite a bit by the industry. This is not an amateur thing. And I'm pretty sure that people that look at this will build games like this because this is supposed to be the industry standard. This is no bueno for AI. And we've seen 17 versions of this image. I tried to find the crappiest one, just to differentiate a little bit. And yeah, we all understand this, right? We all know what this means. However, what we don't know or we don't talk about is when does this happen, right? We have a render loop and an update loop and a network loop, and we know when each one of them needs to happen. Where is the sensing loop? When does it happen? When is the acting loop? We have not had that discussion. We just have this image, and you go yeah, we sense it, and then we act it. Great. And then we think, and then it's, OK, the time that you're thinking, what's going to happen with the game? How do you know it's a good moment to interact with the game and it's not the game now that he's thinking? So yeah, it's a great image. It's succinct. It kind of drives the point. But we need to start asking us, when does this happen? If we want to move out of Atari games or Mario Bros, we need to start talking about this for real time, right? This is a little bit of a pet peeve of me. If you look at Unity, documentation and you're like, hey, I'm making my game. I want to shoot a rocket when a spacebar is pressed. This is a snippet that you get. This is terrible for AI because the AI cannot press down space. For how long should it press it? Like, you need to tell the bot how to interact with this. It's roughly the same thing, but now we have a Boolean variable that we can make our bot interact with. And then that fires. It still works the exact same way. But now AI is a little bit happier. The bean starts to smile. Data. Clean data. So game studios are terrible with data. I cannot talk enough PS about that. And I see some of the other speakers are already nodding heavily. Data is hard in games. States are complex, etc. Right? And then they're like, yeah, our data is clean. Nah, you just normalize your data, but it's still pretty dirty. No, now it's clean. It's like, no, you just remove the outliers, but it's still pretty messy. At some point, we're just like, are we even trying? And then we get to that point, and we're like, yeah, your data is usable. We're starting to be like, it's starting to look good. Oh, by the way, are we versioning this data? Because, games get patches. Games get changed. Puzzle, you launch your puzzle game with like 15 levels, and then you have 4,000 levels. And sometimes companies get creative, and they're like, yeah, we just changed the level, but we didn't change the ID of the level. So now you have data that says that this level is hard, and data that says that level is easy, but they're not even the same level. And this type of question, right, is player A on level X the same as player B on level X 6 months later? Is the data going to look the same? The answer is probably not. Therefore, we need to version that. Is an item the same after a rebalance patch? We need to version that data. For the love of God, put your data version on the data. It's very simple. So how do we get to a happy bean? How can we make our friend over here happier? I think this is where we want to go. And if you remember a few slides ago, this is the modern game architecture with a little bit of a twist. I'm advocating for separating your game logic a little bit from the engine. Make it less married with it. You don't need to. Even if you're doing a very simulation-heavy game, you can separate them. There are a few techniques using things like events and actions. So you can just make it event-based. Your game sends an event to Unity. Unity consumes it, returns events to your game, and they don't need to be married in like a deeply way, right? For the love of God, separate multiplayer from AI. I think we have heard a lot from several talks around like when we're doing multi-agent stuff. Sometimes you want to like freeze the other players, etc. Freeze the entire environment. Don't make them log in. Don't make them do like all the pony dance to get into your servers. Seriously, keep them separated. Mock it. Give them super credentials. Create a test branch that is logging off. I don't know, but please help us here because you're shooting yourself in the foot. So what do we need? Clear moments for a stable, for a state and actions to be captured. As I was saying, we need like a sensing loop, an acting loop, and a thinking loop to be part of this thing. Let's give good windows for capturing this stuff. Everything that happens online needs to be mockable. Your bot shouldn't be needing to logging into the chat server to be able to play. And an answer that we sometimes get here is like, well, what if we just start to learn harder from pixels? I mean, you can always learn from pixels, right? Right? Can I grab just part of your frame buffer? Can I grab your frame buffer before you have finishing all of the post-processing that adds a bunch of blur? Like, is your game ready for that? Or are you just trying to slap me the end buffer as, now you can learn from pixels? Like, yeah, but it's not as easy, right? We will not just plug into the screen directly. We need a little bit of more control on that. And the you can only learn from pixels answer will probably only take us that long, so long. And apparently it took too much coffee and I ran through this. So yeah, any questions, comments, or curses, I'm very open. So yeah, thank you for listening.